Hello and welcome to the Department of Mechanical and Aerospace Engineering's information session. Today, we'll be going over who mechanical and aerospace engineers are, what we do, and what you can look forward to at the MAE department at NC State University. So let's clear out some of the misconceptions about mechanical and aerospace engineers. People often associate mechanical and aero engineers to mechanics, astronauts, or pilots. While those jobs are really cool, that's not what you'll be learning to do here. As a MA engineer, you will be trained to design, build, and test technologies in various industries, including jet engines, renewable energy industry, HVAC units, from small scale houses all the way to large scale industries, nanotechnology, biomedical, and finally, structural industries, whether it be for cars, trucks, or even aircrafts. In short, as a mechanical and aero engineer, you will be responsible for building technology that powers cities, manufacture goods, and allows the pilots and astronauts on the left to fly, keep them flying, and bring them back down safely. So why would you choose aerospace or mechanical engineering as a course to study? If you've been passionate about anything that flies, whether it be an aircraft, spacecraft, or rocket, aerospace engineering is the place to be. On the other hand, if you're passionate about automotives, renewable energy, biomechanics, or are just interested in engineering but are not sure of which area, mechanical engineering is a great option as it is one of the broadest areas of engineering. But end of the day, final question you need to ask yourself is why you are interested in aero or mechanical engineering. So coming to the ME department NC State, once you graduate from here, what can you expect in terms of career options? NC State University's Mechanical and Aerospace Engineering department is extremely well known in the industry, and we have a very, very strong alumni network in some of the top companies, including BMW, BP, Caterpillar, Duke Energy, GE, Lockheed Martin, and more on the mechanical engineering side, and some of the leaders in the aerospace industry, such as Boeing, Delta Airlines, NASA, NAVAIR, and Honda Jet. And these are just to name a few. There are many, many more that hire graduates from NC State University. The average starting salaries based on 2019 for the mechanical engineering side is around $64,000, and for an undergraduate from NC State on the aero side, it's around $63,000. So how do you go about getting into the MAE department at NC State? Before you even consider for an admit into the MAE department, you'll first have to be admitted into the College of Engineering at NC State. For more information on this, we recommend you contact COE representatives who will be able to give you more information on AP, IB, and transfer credits, and also SAT score requirements, high school GPAs, etc. However, as a general rule of thumb, we can recommend a few things. Number one, for students who usually come into the engineering program, they have AP credits for calculus and physics. Although this is not a requirement, the more physics and math exposure you have in high school, the better it is when you come into your engineering degree. Second of all, as engineering majors at NC State, you'll require 21 credit hours of general education courses in humanities, social sciences, etc. And these are generally referred to as GEP courses. You could try and get some of these out of the way before college by taking courses like psychology, history, etc. And finally, and most importantly, please do not feel the pressure to come to college with a super advanced standing and jump right into sophomore level coursework. It is okay to retake these courses for which you have received AP credit for during your first year while you get grounded and acclimated to college life. Secondly, engineering, end of the day, is just applications of the fundamental physics and math laws that you are currently learning in high school. The only difference is that in high school, you have one full year to actually absorb all the material, while when you come into engineering, where you'll be learning how to apply all of this, you will have just 6 months in which you'll be learning different subjects altogether, and it can get really, really crazy if you are not fundamentally very, very strong. So bottom line is that more than trying to take too many AP courses, you'd rather take one or two AP courses, but get your fundamentals very, very clear so that once you start your engineering degree, your courses are going to be a lot more simpler as compared to you taking many AP courses, not really understanding too much, and getting lost in all the courses and the material that's going to be thrown at you within a short span of 4 to 5 months. Once you're admitted in the College of Engineering, you'll be a freshman who'll begin as an engineering first year with an intended major. You will then apply to CODA or change of degree application into an engineering major of choice after your first 2 semesters. The CODA admissions are basically capacity driven, and the GPA is based on Calc 1 and 2, physics and chemistry, which are courses that you'll be taking during your first year. Although requirements vary year to year, they basically depend on the academic performance and the number of applicants. But bottom line is, don't stress out, but just simply do as well as you can in your first year courses, and usually things will work themselves out. As far as September 2020 stats go, there were 53 students who were admitted into the Aero program, out of which 56 had aerospace engineering as their first choice. On the mechanical engineering side, we admitted 169 students, out of which 161 students had mechanical engineering as their first choice. The average first year GPAs for aero and mechanical were about 3.67 and 3.56 respectively. So coming to scholarships, as a first year student, it will be the College of Engineering that will be able to provide scholarships for freshman students. However, after you CODA into the MA department, students will be eligible for both College of Engineering as well as mechanical and aerospace engineering scholarships. As far as the latest numbers go, approximately 80 of the top MA students receive a College of Engineering or MA scholarship each academic year, with the scholarship awards ranging from $500 all the way to $3,000 per academic year. So now you're an MA with hopefully a great scholarship. What's next? The MA department has approximately 1,200 undergraduate students, out of which 1/3 are aerospace engineers and 2/3 are mechanical engineering majors. We also have a great graduate program over here with over 400 graduate students divided between the master's and the PhD program. As far as course sizes go, earlier courses that you'll be taking during your sophomore year, like statics or dynamics, can be as large as 80 or more. But generally, if you do have a class that is very, very huge, they are divided between sections, and each section will be taught by a different professor. As you go to advanced courses in your junior and senior levels, your class sizes can be as small as 30. Overall, you'll usually see an average class size about 60, with the number decreasing as you go from your sophomore all the way to your senior year. So who teaches these MAE classes? The majority of MAE lectures and design courses are taught by the research faculty, teaching faculty, or lecturers associated with the MAE department. The labs are managed by teaching faculty, but are also taught by the graduate teaching assistants in the department. Now, as a mechanical and aero engineer, you're here to build stuff, whether it be something that will fly or something that drives or does both, right? So how much of your experience over here is actually going to be hands-on? So most lecture courses are analysis and design based, but you'll be getting actual hands-on experience from your sophomore all the way to your senior level through your lab courses, where you'll be applying all the knowledge that you gain from the lecture courses into running experiments or programming Arduinos and building systems, building and programming systems. And as you go to your senior year, you are required to complete a capstone senior design course, which will basically involve you applying all the knowledge that you have learned in all the 3 years into a final project. Another way to get hands-on experience would be to join one of the many student clubs that are associated with our department. The student clubs associated with the ME department include Wolfpack Motorsports, Yale Robotics Club, Hyper Rocketry, ASME Design Team, Solar Pack, SEDS, and the Engineering Application Club. Most or all of these clubs regularly participate and win in international and national competitions. So, hands-on experience, this is the place to be, where starting from your sophomore level itself, you can be part of one of these clubs where you can apply your book knowledge to actually building different things or different technologies for various engineering applications. Even if for some reason you're not able to get involved in any of the student clubs or be part of the undergraduate research, you will still have the opportunity to apply all the theoretical knowledge that you've gained from your junior year onwards into solving practical engineering problems through the mechanical and aero capstone design courses. On the mechanical engineering side, we have a very unique program at the ME department because all of the capstone projects are sponsored by the industry. Some of the previous industrial partners that we've had are Caterpillar, Denso, the US Army, Klausner Home Furnishing, and Volvo. So as you can see, a very varied range of industries. We've also had private citizens come in and sponsor projects through the ME capstone design course. On the aero capstone design side, students are divided either into space teams or the flight teams. On the space side, students are either involved with design, building, and flying high-powered rockets or working on small spacecrafts or satellites, also known as CubeSats. On the flight side, students either work on fixed-wing aircrafts, where they'll be designing aircrafts based on the specification given, or design, building, and flying multi-copter drones for a given application. You also have the option of being part of the student organization chapters of international societies. Some of the student chapters that we have in the department are the American Institute of Aeronautics and Astronautics, which is AIAA, or one of the premier mechanical engineering societies, which is the ASME, ASHRAE, the ME Honor Society, which is Pi Tau Sigma, or the AE Honor Society, which is Sigma Gamma Tau, and Women in Mechanical and Aerospace. Some of the other opportunities you will have as a student in the ME department include being an undergraduate researcher in one of the labs that are headed by the many faculty members in our program. In fact, the MA department regularly offers student awards for those who do such undergraduate research. You also have the option to study abroad in many of our partner universities for a semester or during the summer. You are fully encouraged to do co-ops and internships in some of the many companies that hire from NC State. We also have the Engineering Entrepreneurs Program that can be done as an alternative to senior design. We have our MA Ambassadors Program, our Faculty Mentor Program, and we regularly host our alumni who come into the department and talk to some of our students and share with them their experience, talk about their industry and some of the challenges and some of the ways that you can be part of that particular industry. We also offer the E490 FE exam prep course in our senior year for professional engineers. And last but not the least, we have a very vibrant and diverse graduate program in the department. Now, as far as College of Engineering graduation rates go, unfortunately, we don't have it for the MA department, but for the overall College of Engineering, for those students who started in the College of Engineering, 37% of them finish in the College of Engineering within 4 years and 65% within 6 years. And those 6 years, the extra 2 years could be because they've been doing internships or co-ops. On the other hand, for those of those who start in College of Engineering, finish elsewhere within NCSU, 46% of them in 4 years and 81% of them in 6 years. So if you're already thinking about graduate school, or once you're done with your senior year and you are interested in a particular area of mechanical aerospace engineering that you want to explore further, or you've been involved in some undergraduate research that you'd like to continue on, or just are in so love with the M&E department that you want to stay a little bit longer, the graduate program at the M&E department is an excellent option. The M&E department has extremely accomplished faculty who conduct cutting-edge research in various areas of aerospace and mechanical, including aerodynamics, fluid mechanics, control systems and design, structural mechanics, thermal sciences, biomed, and nanoscale science and engineering, to name a few. The great part about a lot of the research that we do is that it overlaps with nearly every other field of engineering, giving graduates a broader view of, or a broader education in engineering. With this, we come to the end of our info session. Following this slide, we have a virtual tour of our department, including our state-of-the-art facilities and labs, which we hope will give you a clearer picture of what you can expect at the M&E department. As a final note, we encourage you to stay connected to the M&E department using our handle at NC State MAE on various social media platforms, or visit our website on mae.ncsu.edu for regular updates. We thank you for considering the M&E department, and we hope to see you soon. Go back.
Buckner. I'm a senior in mechanical engineering, and welcome to Engineering Building 3. This is the house of mechanical, aerospace, and biomedical engineering departments. This is our computer lab. It has 24/7 access to students so they can work on their homework and assignments. It has computers that are compatible to run MATLAB and SolidWorks software, which is really helpful for students to be able to get their work done for different classes. And it's just a great space right off the lobby of EV3 that students can come and work quietly. This is the Thermal Sciences and Energy Systems lab. It's for MAE Class 306, which sophomores take. In this lab, students get to work with thermodynamic systems, learn more about fluids. A specific lab that's a lot of fun is done in here is every group is given a leaf blower to act as a model of a wind tunnel, and they use a pitot tube to measure different pressures across the cross-sectional area of the flow. And they get to learn a lot about that. They learn a lot about fluid flow in this class, and it's just a lot of fun. This is a structural mechanics lab. It's the first lab that students come into when they come into the department. It's their first time getting to use different instrumentation. For example, they get to learn how to use a multimeter, a power supply, and a oscilloscope, and a function generator. They also get to practice soldering, which is a really awesome tool to be able to use. In this lab, you get to build your own fiberglass and break your own fiberglass, which is a lot of fun. And you also get to use strain gauges to see the different stress and strains that's put on a soda can when you open it, and then you get to drink the soda. This is a Dynamics, Vibrations, and Controls lab. It's the final lab that seniors in mechanical engineering take. This lab follows the curriculum of the controls class, and currently students are working on programming this PLC and learning about ladder logic and how to move this arm from one side to the other. And later they'll work on this plant and learn how to control it using different types of control logic. This is one of the large lecture classrooms, and it's where most of the undergraduate classes are held. So students will have classes like thermodynamics, solids, and fluids in these classrooms. They normally hold 80 to 100 people, and right now they're being utilized by Engineering Online, so the professors can still lecture in here in an empty classroom, but the students are connected and they can see them on these screens. This facility is used for undergraduate aerodynamic lab courses where students come in and do aerodynamic testing of vehicles such as aircraft, cars, and propellers. This is an NCSU subsonic wind tunnel. It was purchased from NASA and is driven by a 250 HP motor that drives a 3-blade propeller from a World War II aircraft. This is the anechoic chamber that's used for acoustic testing for both undergraduate and graduate mechanical and aerospace research. This is one of the 2 aerospace senior design labs. It's in Engineering Building 3. This is for the aircraft capstone senior design lab, while the space and multi-copter capstone is across the hall. So this is a room where students can come and they can design and build and work in teams to get their project done by the end of the spring semester. This is a mechanical engineering senior design lab. Mechanical engineering senior design is unique because it's entirely industry sponsored. This is where students come and they're required to receive training to use these machines. They can also work together in teams and build and design their projects in this space.